Nature's connections can show up in the most unassuming places. For decades, people have watched curiously as ants collect seeds. These seeds often come with a fatty attachment that entices ants to take them underground, which is a nifty tactic employed by plants to get their seeds dispersed. This strategy, known as myrmecochory, has guided ecological thinking for many years. Recent observations have shaken up this old concept, as a surprising twist has come from an unlikely source: oak galls produced by certain wasps. 8-year-old Hugo noticed something puzzling one afternoon. He saw a small parade of ants scurrying across a path, hauling what he assumed were regular seeds. His father, named Andrew Deans, took a closer look and realized these were oak galls, not plant seeds. Galls are growths shaped by wasps to ensure a safe shelter in which their larvae can develop. Hugo's discovery launched fresh inquiries into how wasps might be tricking ants into unwittingly providing protection and resources for their developing young. Andrew Deans is a professor of entomology at Penn State. His experiences with insect classification and ecology helped shape the next steps in understanding how certain wasps manipulate ant behavior. Working with other researchers, he looked at the structure and chemical makeup of the oak galls, aiming to see whether these odd lumps mimic the enticing attachments found on seeds. That line of inquiry opened the door to a bigger story about insect collaboration. Research into seed dispersal has shown that ants love fatty acids, which they harvest from specialized structures on seeds. Many oak galls have a similar coating, sometimes called a hood, that contains these appealing molecules. Once ants bring the gall inside their nest, they devour the fatty portion but leave the rest. Within that intact shell, the wasp larvae stay hidden from predators. The parallels between seeds and galls have stirred fresh debate among entomologists. The biggest revelation for many scientists is that these gall hoods may imitate the scent of deceased insects. It's amazing how these structures mimic the chemical profile of dead insects, one of the main food sources for ants, said John Tooker, professor of entomology at the University of Pennsylvania. This discovery sheds light on a possible reason behind the ants' brisk retrieval of galls. They are likely to think they have found a reliable meal, but end up giving wasp larvae a free ride and shelter instead. Millions of years before humans paid attention to them, galls were a feature on oak trees. Fossil records show that wasps and oaks have had a long relationship, although it is not clear when ants became part of the mix. Some experts propose that wasps first persuaded oaks to create galls, and then evolved ways to draw ants into the equation. Others believe the ants' interest in fatty acids nudged the wasps toward this chemical strategy. Nature relies on countless overlapping interactions. These gall-making wasps provide another example of how two different insects might develop a shared connection that benefits one party more than the other. While ants enjoy a quick snack from the gall's fatty hood, the wasp larvae receive a safe refuge for their development. This unintentional partnership hints at how life weaves complex networks that bind different species together, often in ways that scientists have missed. Each time new details emerge, the broader narrative of ecological ties evolves. This should make us think about how much we still don't know about ecosystems and the need to preserve biodiversity, reflected Andrew Deans. The researchers stressed the importance of keeping ecosystems intact to maintain these intricate ties. Oak trees and the wasps that make use of them face threats from habitat decline and changing climates, which could unsettle the entire chain of relationships. When environments shift, the ants, the galls, and the plants lose a vital piece of the puzzle that supports their survival. Hugo's brief observation highlights how small moments can spark big changes in what we know. Nobody expected a child's quiet stroll to upend familiar ideas. Researchers are now curious to see if other insects use similar methods to coerce ants. By peering into everyday wonders, people can gain a deeper appreciation of how species interact. Each fresh insight builds on the last, emphasizing the value of patient exploration and open minds in science. Read the full story on Earth.com in the description.